So this is a problem that requires us to know the unit circle. If you're very comfortable with it, this is actually quite an easy problem. It's just a bit veiled. And if you don't know the unit circle, I really encourage you to make sure that you dive into it, because you're going to run into it once every 2 exams that you need to know the unit circle, maybe 3 if you're lucky. And if you're looking for a very high score, this is worth making sure you know. I do recommend you do this after you've already mastered everything leading up into Algebra 2 and geometry. Because honestly, this only does show up so rarely that for you to sacrifice those others, if you only have a limited amount of time, it's not worth it. With that said, if you have all those mastered, this is a problem that they're testing our ability to recognize the different coordinates that appear on a standard unit circle. This is not a standard unit circle, and we see that because at this point you can kind of see that it's within like the first third of the unit circle, and typically that would be root 3 over 2 and 1/2, but this is just root 3 and 1, which tells us that the radius here is actually 2. This unit circle is twice as big as your standard unit circle, but the ratios remain the same. And so what that means is, if we think about how far up must this be if everything's being doubled, but the ratios are the same, what that means is that this measurement is the same, which means that this is still 30 degrees, which tells us that this is actually still pi over 6. And that asking us what a is in pi a radians. In that case, it is 6, the denominator. And so the answer is just that, 6.